In this course, students learn the basics of propagation, radio wave propagation, and wireless link design. They also gain practical experience in designing and implementing a wireless system. You spend 3 years of your life doing analysis, and finally, in these major design experience courses like EECS 430, Radio Wave Propagation and Link Design, you get to exercise your creativity. So you're implementing something, you're coming up with a new system. You actually show the creative side of being an engineer. The student projects in this course are sponsored by industry as well as agencies. So the student teams team up with point of contact at a company or at an agency and then work with them to hammer out the specifications of their project. In previous years, students have been directly hired as a result of their major design experience. Now you hear about a few student projects or student team projects that have been done in the past. One is a GPS tracking system. Another is an audio surveillance system, as well as a third project, which was an antenna system for space weather exploration.
We had a mobile unit, which we call the transmitter in general. But what this mobile unit had on it was a GPS receiving antenna that took the GPS data and sent it through to a transmitting antenna. That transmitting antenna took the information and sent it into the air, where it propagates through air, and then it is received at the receiving unit. And this receiving unit is essentially just an antenna and then some electronics to process the signal that you get, and then a computer so that you can watch as someone moves holding the transmitting unit.
My project was the recycling cell phones project, better known as the MacGyver project. What we did was we were teamed with Recellular, which is a recycling cell phones company, and they basically gave us a whole bunch of used cell phones and said, make something cool. What we ultimately decided on was making an audio surveillance system, which would be wireless. And what we did was we took from the cell phones as many usable parts as possible and constructed listening devices, basically eavesdroppers. We had 3 of these and one central receiving unit which could listen to real-time audio from any of the 3 transmitting listening devices.
Okay, right now this is a demo of my team's project. I am not mic'd up. This is my system in use right now. I am holding one of the transmitters, and about 25 meters away from me is the receiver.
I'm Matt Bennett. I'm the student project manager for the Radio Aurora Explorer satellite, and the RAX satellite is an NSF-sponsored mission to study space weather anomalies. So I proposed to the professor in charge of EECS 430 that students help design and build this antenna.
I'm Nicholas Underwood. I'm senior in electrical engineering. I took 430 because I became interested in electromagnetics in EECS 230 as well as EECS 330, and it was the best succession or the best MDE course to take EECS 430. And also I was interested in the theory and actually participating in a practical project that I could construct my own antenna. The semester before I took EECS 430, I was participating in a project called MCube, which was part of the Student Space Systems Fabrication Lab. And we built a similar model to RAX. It's much smaller, but I wanted to get more involved in 2 other projects, so I heard about RAX. We both took EECS 430 together, so it was a good fit for us to recruit other students to participate in our project.
I think the best thing about 430 was the opportunity to develop my own antenna. I mean, there's lots of projects that you can look up on the internet on how to build your own antenna in your own garage, but you can't really analyze it and test it very carefully with the instruments that are out there. So to be able to work in EECS 430 gave us the opportunity to work in the anechoic chamber. So I actually put the spacecraft in there and got to see what the radiation pattern looked like. We also got to hook it up to network analyzers and precisely tune the antenna elements to make sure they matched to the transceiver that we were using. And so with all that equipment, we were able to have and build a very optimal antenna, and I think that was an exciting part about working in 430 versus doing it on my own.
Professor Grbic was amazing, nothing short than an excellent teacher. He taught me in theory that I much needed for my job that I'm going to have after I graduate.
After I graduate, I'll be working for NASA's Jet Propulsion Laboratory in Pasadena, and I'll be continuing similar work doing mission concept development and also working with testing the spacecraft as well.
So EECS 430 helped me get my new job because I'll be doing work for NavAir on the East Coast, studying F-18 Hornets using antenna arrays and studying the avionics of it.
So yeah, that's a question I get is, what equation do I use? And it's always hilarious because, there isn't an equation, and then it's kind of shocking, but then they get over it and they have lots of fun. Yeah.